but I'm going to be talking about how the history of this land has shaped what we have here today. There was, back a few hundred years ago, a man named William Bartram who went across the South. He's considered to be the first great naturalist that this country ever produced. And 1 year to the month before the Declaration of Independence was signed, he came through Butler County walking on this little ridge behind us on his way to Mobile. And he stopped. He was a naturalist, a botanist. He looked at this woods we have here in Butler County, and he was amazed. There are few places you can go and find a richer forest than what you have here in terms of numbers of species. Now, one of the things that I'd like to talk about in this 15 minutes or so that we have is what leads to this great diversity of species we have in our forest in this particular part of Alabama, and particularly this little stretch along here that's known as the Red Hills. One of the things that causes this great diversity, or I should say fosters this great diversity, is the way that this land has been cut by streams over time that's produced a diverse landscape. This is not the coastal plain that we've been said that we live in, which is a flat area of land. This has a lot of different habitats, a lot of different shapes to it. Now, look back behind me at this little bluff that we're looking at, and there's some very interesting things going on right here. This would be one of the more diverse forests that you would find in Alabama. If you went up this little draw right here, you would probably find 100 species of native trees in that little draw. Now, there's things about the geography and where we're standing that lead to that kind of forest diversity. One thing is, what direction does this bluff face right now? Now, all you have to do is look at the sun to see which way it's facing. Where's the sun in relation to us?
Back behind.
All right. In which direction, as we're approaching noon of the day, we're not an hour or two off from it, which way is this bluff facing?
West.
North. This is a north-facing bluff. Now, part of the secret of this forest diversity has to do with what's able to hide behind north-facing bluffs. Now, I'm going to take that a next step. What kind of rock are we looking at that's coming out of the bluff over here?
Limestone.
It's limestone. Now, can anybody tell me, I picked up a chunk of this down in our feet. If you look real carefully right here, you can see that this little chunk of limestone has all sorts of little white slices in it. Those are pieces of ancient shells. And this rock has been studied because of certain fossils it has. We can tell you with as much precision as 500,000 years can give you, this rock is 63.5 million years old. And the reason we know that is it's got a particular creature in it that looks like this right here, a kind of fossil. And this kind of fossil, Butler County is known for. You know, this is spread out, but you can go anywhere else in the state and you're not going to find this little guy here. In fact, people come from all over the world to study this rock and the other things, the other kinds of creatures that are around it. What would we call this critter today if we saw this out in the ocean? Snail. It's kind of like a snail. It's got a curved shell. It is a mollusk, but it is a particular kind. Comes out at night in the Indian Ocean. It's got these little tentacles that come out like this. It's a nautilus. And this is not our nautilus of today. This we call a nautiloid, which means it's nautilus-like. And you notice that its shell is divided into little sutures. The animal grows out and makes new little parts to live in as he goes along. And here's the little preserved piece where the actual center part of this, all his little guts and things were in that little tube you see right there in the middle. Limestone has some characteristics that's really interesting and important about how the land gets shaped. That wouldn't do too much right there, would it? Geologists.
Thank you, Faye.
I was about to clean a rock off for you. Here's a rock I picked up down here in the creek. Now, I can't look at this. Have a pretty good idea from seeing those shells in there that this is a piece of limestone. But geologists carry in the field with them a little bit of weak acid. Now, not strong, because you know, if it leaked in your pants, you'd be embarrassing. But limestone has a particular response to any kind of acid. Weak acid like this, hydrochloric, muriatic acid if you've ever cleaned off towels. It's also the acid that does your digesting in the stomach. But notice what happens when I drop this acid on it. Hey, one of you kids that's had this in science class, what's going to happen when I put this on? Anybody? It's going to bubble. And what are the bubbles going to be?
Bubbly. The rock. The limestone.
Keep going. Keep going.
And
Get you to think a little bit.
chemical reaction.
All right, watch this. Let's see. I'm just going to pour a little bit on it. You see that little mist that comes up and all that bubbling going on? That is carbon dioxide that's been stored in this rock for 63.5 million years from the time this was this seafloor. And that carbon dioxide is going back into the atmosphere here, rejoining the carbon dioxide that's in our atmosphere today. Now, over time, limestone gets rounded, like you see this piece here. And that's what causes this beautiful sculpting that we see going on the creek right here. It's not so much the water pounding against it, although this is the cut bank of the creek. You can see the creek, if it were 20 feet above our head and it gets way on up, look at the flotsam way up on the bank there. We'd be standing under 15 feet of water during a big flood. That carves it a little bit into that shape, but you notice that there's kind of a flow to it. That's limestone being dissolved away by rainwater. Just normal rainwater weathers limestone away. And on the large scale, that's what shapes this part of Alabama. The valleys are going to be on limestone. They're going to be flat and less topography. The harder rocks, like way up on the hills, will be sandstones and other hard rocks. Burstone, which is a quartzy rock. Yeah, let me see. Now, John said if you get fortunate enough to see something down in the creek today that you'd like to take with you, both of these are parts of nautiloids right here. You have to look kind of close to see them, but see the little spiral, the little curve that are in them? He said you could take one if you happen to get lucky and see one down in the creek. And
that's very generous.
that is generous, you know. And don't please put it on eBay and sell it for $50 like it's worth. I mean, you know, people will pay that easily. Other things that you can find in the creeks around here. What does that look like? Looks like wood that's turned to stone. In fact, feel the weight of that right there. See, and you can see the tree rings in it.
Jim, did you have to clean that one off, or?
No, it got cleaned off by the water.
Okay.
But now that one has come right out of a bank like this right here. The reason I know is it's not rounded much as the edges of it. If it's been in the water a while, it's going to have real smooth, rounded edges. And you can see the wood fiber in that. And I also know that this is from a palm tree that grew here back in the Paleocene epoch, because they're not rings in this wood, they're vascular bundles. It's like a little fibery pith inside a cornstalk that this tree had. That's a tropical plant. It wouldn't be out here today, maybe farther south in Alabama. Oops. Maybe I better give some room over here. We would be adding another fossil to the creek. Now, some of the things I'd like, I know we don't have a lot of time, but I want to try to explain a little bit what leads to this kind of forest diversity that we're talking about. Why is a north-facing slope more likely to have more different things on it than a south-facing slope? Well, let's look for one thing. You see far more species of trees right through there than you see on this bank over here. Do you see any cedar trees at all on this part right here? There's something different in the habitat style from this bank facing north and that bank facing south. Look how many cedars you see along there. Now, there's a particular kind of fern that you'll notice growing up on that bank that I mentioned last night that can be used to tell you what the geology underneath the ground is. That's limestone because that is a southern maidenhair fern. It's a limestone indicator. Now there's two reasons why that fern is up where it is. It likes the lime that it's growing on, but it's got a nice little drip of water coming out of the hillside there. You can see where the water drips the most because that's where it's concentrated. Now that drip is important because that creates a special environment on this north-facing slope. That little drip goes on all year long. Water trickles in the wintertime in that slope. It works its way down and it infiltrates very slowly, and then it wicks out all summer long. Now that makes a special climate right here that you don't have up in that field. What's different about the microclimate right there than you would have 100 yards away? The moisture does what though? How does it change the climate?
Makes it cooler?
Huh?
Does it make it cooler?
Cooler, yes. Evaporation of that cliff right there lowers the temperature of the air right here several degrees. And that opens up niches for more northern species of trees, for example. Maybe this basswood over us right here, that's an Appalachian tree. This is not the Appalachian, so what it's doing here, it's left from thousands of years ago. This is an Ice Age relic that goes through here. It's right at home, but basswood is not something we would expect to see in South Alabama. But on north-facing slopes, because of that microclimate, it is here.
And that's the same reason we have the shooting stars.
Yep, shooting stars and other things. And I'll show you another little plant. How many of y'all heard my talk last night about plant distribution and all? Okay, come over here and I'll show you something special that you can easily pass by without knowing what's neat about it. Here's a little plant growing along the creek that's called heartleaf plantain. Plantago cordata is its scientific name. And this plant right here is classified under plant rarity scale in Alabama as S1, which means it's state listed as the rarest group of plants in the state. And it means it's found in 5 sites or less in the state. Now here's an interesting fact that I pointed out last night. If you started here and you drew a line to the northwest from here, 180 miles, you would hit the next colony of this plant in Colbert County, Alabama, in our backyard up there in Cane Creek drainage. Now there's a great mystery in that distribution. Why is it found here and not 100 yards away, or 10 miles away, or 50 miles away? Some natural law is at work here that we would, in the world of science, would just love to know about. That's a mystery there. Now, every time I talk to people about rare plants and all, the first thing that comes to many landowners' minds is somebody going to come in and keep me from doing what I want with my land? And in Alabama, that's not going to happen. You know, there's nothing, an S1 plant, you could bring a bulldozer in here if you wanted to and just bury this underneath a big pile of sand. But if I were the landowner, I would be proud to have this plant on my land. That is a wonderful little piece of important nature right there that not everybody's going to have. And this would be a great little thing to point out to kids, to point out visitors to your place. If you have a rare plant there, it means there's something special there about that environment. And if I were a landowner, I would figure out some way to protect that plant. I would say, I want to keep this because this has been here a long time. We don't know why, but they're going to be guys over at Auburn, young college kids come in here working on their master's degree or their doctorate, and they're going to be working on these scientific mysteries like that. And this is right here waiting for them to work on. So that would be my argument why you would want to have that Red Hill salamander back in that little draw right there. Whatever trees you cut out of that little draw, you wouldn't get it as much as the pleasure of knowing you had something like that on your place. So this would be my argument about that, is that the more you understand your land, the more you know about it, the more you know about the history of it, the more interesting living on that piece of land is. And your kids are going to like that, your grandkids are going to like that. That is just a totally good argument for appreciating what you have. Now, I'm going to really quickly, everybody asks me this too, where do I find the good fossils around? Well, let me show you a few kinds of things you can pick up around in this area.
Get a picture of it too. You reckon we got it on our page?
They're close enough.
You see those shark's teeth? And right here is a piece of fish poop. Oops, she drops it quickly. It's fossil fish poop, and because it has a lot of organic matter, it even looks like poop, doesn't it? See the little lumps in it? It's made out of iron pyrite. It's pulled pyrite, pulled iron and sulfur out of the environment. And shark's teeth are one of the more common kinds of fossils. Virtually every creek around here is going to have them. But now they're not equally distributed around that creek. So here's the secret thing about where you look to find them. And you can kind of look through that if you like. I'll pass it around.
You know, put that back in.
Where would you, wouldn't that be fun to take that into your teacher one morning and say, make her put it in her hand and say, you know what that is, teach? That's a piece of fish poop, fossil fish poop. Where would you go in this creek? There are shark's teeth right here, but you can really narrow it down. You can go with this lady over here in the red shirt, Faye Lacefield, and she is a fossil hound. She spots them from that far away. To really find them, you would go to a place like, see that sandbar right there? That sand has settled there for a reason. During the flood, this water comes down with great force, and there's an eddy right there in the creek, a place where the creek spins like this. And when the water goes slower, all the little things being carried by the water settle out. Gravity's your friend. It would settle right there. But now, say you wanted bigger fossils. Say you wanted to find that mammoth tooth down in your creek. Would you look there? It wouldn't settle out there. Notice everything is almost the same size on that bar right there. That'd be great for picking up shark's teeth, but to find that mammoth tooth in your creek, and they're there, every creek around here has got them. Look down below us at the size of the rocks in that bar right there. Those are big, heavy chunks. They settle where the water has really been swirling around, and all the things fall that are about the same size. So that's where the big mammoth tusk or mastodon tooth might be in this kind of creek. And once you learn those little tricks, it is great fun. This is part of Alabama's history that you are around every day. And if you learn to see it, it's right there. And everybody likes to do that. Think of, on a summer day, how neat that is to go out in the afternoon and spend some time with your kids walking in the creek, down in the shady bluffs like this, and picking up things that are just jaw-dropping and significant like that. They said we're about ready to pack up. Anybody have any questions that you'd like to ask while we're standing here about forests or fossils or this part of the world.
Jim, you said the plantain was found in 5 places in Alabama?
It's to be S1 listed, and you can Google this about plant classification in Alabama, rare plants, and you'll come up with this little scheme, but it's 5 sites or less.
Are the other
Or
4
some-
probably up in North Alabama? Or?
Well, they're up there, and maybe over in the Coosa Valley too,
Okay.
somewhere northeast,
Yep.
where there's limestone exposed and you know, a particular environment.
Okay.
But it also is certain kinds of trees that are being attacked right now, like American chestnuts. You may have, this woods has probably got some chestnut sprouts here, left over from back when the chestnut blight. They're still sprouting up from the stumps, but that's listed S1 in Alabama. Butternut or white walnut is going to be back in here somewhere too, and that's being attacked by a canker, another disease. It's listed S1 because it's highly threatened too. So that just means that there's a significant chance that they may be gone without the right kind of protection. Yes. Okay.
Okay, got a
All right.
load.
Well, y'all have a good afternoon and evening out